All right, the next and final thing that we're going to cover in series is going to be the topic of varying sign series, which is also known as alternating sign series. So an alternating series is a series in which the terms strictly alternate in sign. In other words, no two consecutive terms are going to have the same sign. So your terms are going to have to go positive, negative, or negative, positive, and so on. You cannot have positive, positive, or negative, negative anywhere in your series. All right, so if we look at this first situation right here, when we have sigma -1 to the n power times a sub n, this is one way of representing an alternating series. This would be another way, which is just slightly different. The exponent is n plus 1. The only difference really between this and this is determining what your first sign in the series is going to be. For example, if this one starts at n equals 0 and goes to infinity, then your first term is going to have -1 to the 0 power, which will be a positive value. And then when you go to the next term, that would be -1 to the first power, which would be a negative number. And then the n is 2 is going to give you a positive value, and so on. Now, what happens is if n is equal to 1 instead of 0, then your first term is going to be -1 raised to the first power, which would be negative. And then you would have -1 to the second power, which would be positive. Third power would be negative, and so on. So you can see all it does is it changes which sign comes first, positive or negative. And the other one does basically the opposite, whereas if this starts out with n equals 0 and goes to infinity, then what you're going to have is -1 to the 0 plus 1, so that would be -1 to the first power, which is a negative. And then when you put a 1 in here for your next number, that's going to be an exponent of 2, which turns this into a positive. And then the next one is negative. And so you can see this was when n is 0, starts at 0, went positive, negative, and then on this one starts out with negative and then positive. So it's just messing around with the signs is all it's doing. All right, so this question is asking which of the following series are alternating. All right, so this right here tells us that yes, this is going to alternate. And in fact, when you're starting with 0, then that's going to give you -1 to the first power, which is a negative number. So not only are they alternating, but your first term is going to be a negative. Your second term will be a positive. That would be when n is equal to 1. That makes it -1 to the second power, which is positive. And then it jumps to negative, positive, and so on. So yes, that does alternate. The next one, looking at -3 raised to the n power. And so if you start out with n is 0, you will get a positive 1. -3 to the 0 power is a positive 1. And then when n is 1, that's going to give you -3 to the first power, which is a negative. Second power would be positive. Third power would be negative, and so on. And yes, it does alternate. All right, so the next one, we have cosine of n pi over n squared plus 1. Now the n squared plus 1 will not determine whether this thing alternates signs or not. Really only this will. N squared is always positive, plus 1 is still positive, so it's always going to be a positive value. All right, so let's think about cosine of n pi for just a minute. We're starting out with n is 0. So when n is 0, you're going to get cosine of 0, which is positive 1. All right, so now let's go to the next number, which would be 1. That would give you cosine of 1 pi, which is negative 1. And then you go to n is 2, which will give you cosine of 2 pi, which is positive 1. And then you'll get cosine of 3 pi, which is negative 1. So yes, this does cause this series to alternate signs. This acts in the same way as negative 1 to the n power, because you're going to start out with a positive number and then negative, positive, negative, positive, negative. All right, so the next one, we're looking at sine of 1 for your first value. Well, sine of 1 is a positive number. And then you would go to, now keep in mind, this is not the sine of 1 pi. This is just the sine of 1. All right, so that would actually fall in the first quadrant. The next value would be the sine of 2. The sine of 2 is also a positive value, so that does not alternate signs. That would be an angle that's in the second quadrant. All right, so let's take a look at this series right here. This series has actually a name for this. It is called the alternating harmonic series. If you will recall in the previous lesson, when you have n equals 1 to infinity of 1 over n, that is called a harmonic series, and that would be, for example, 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and so on. And that harmonic series diverges. So a harmonic series diverges. Also, we think of this as a p-series, and in order to converge, your p-value, which is your exponent right here, has to be larger than 1. If it's equal to 1, it is called a harmonic series and diverges. Now, this one right here is very similar to this one, except your signs are going to alternate. And when n is equal to 1, that's going to give you negative 1 squared, which is positive 1. And then when n is 2, you get negative 1 to the third power, which is negative 1. So what you're going to do is alternate your signs. You're going to have positive 1 minus a half plus a third minus a fourth plus a fifth, and so on. And it just keeps on going forever. This is called an alternating harmonic series. All right, so let's take a look at the table values that are created by this harmonic series. These are your n values, starting with n is equal to 1, and they would just keep on getting larger and larger and larger. A sub n, starting out with 1, and then you're going to negative 1/2, and then positive 1/3, negative 1/4, positive 1/5. So these are just these values that we have right here. And then S sub n, this is the sum of those terms. So for example, S sub 2 would be the sum of the first two terms. Well, positive 1 plus negative 1/2 adds up to 0.5. If you add the next term, you get 0.833. Adding the next term will give you 0.5833. Adding the next term gives you this. Adding this gives you this. So if you will look at the sums are getting closer and closer to a particular value, which means, yes, an alternating harmonic series does converge. So a harmonic series will converge as long as your signs are alternating signs. If the signs do not alternate, then your harmonic series does not converge. This is a graphical representation of what you had on the table. This is your first value, which was positive 1. And then you add the next term, so positive 1 plus negative 1/2 gives you a positive 1/2, plus the next term gives you this value, plus the next term gives you this value. And when you add the terms, you can see that they are alternating on different sides of this value, and this value 0.6931, and there are more decimals after that, but that is the value that this series does eventually converge to. So that leads us to what is called the alternating series test. And here it goes. If a sub n is positive, the series sigma -1 to the n power times a sub n. And by saying a sub n is positive, it means that this value right here will have no bearing on whether this alternates signs or not. The only thing that determines whether you alternate signs will be this value right here. Or it could be written as this, and a lot of different ways that you could actually write this. You could use n-1 or whatever. So this converges if and only if a sub n plus 1 is less than a sub n for all n. Now what that means is that your next term has to be smaller than the previous term. And if your next term is smaller than the previous term, then there are some things that are also going to be taking place. So in order for an alternating series or a series to converge by the alternating series test, there are three things that have to take place. Number one, your signs have to strictly alternate. It means positive, negative, or negative, positive. You cannot have two of the same signs next to each other. The second criteria is that they have to decrease, the values have to decrease in magnitude, which means your numbers got to get smaller. And those numbers not only have to get smaller, but they have to approach 0. So those are the three things that are going to be the criteria for your alternating series test. Notice that the alternating series test cannot be used to show divergence, which means we cannot use this test to prove that a series diverges. This test can only be used to tell if a series converges. And if it doesn't meet these three criteria, that doesn't mean it diverges. It just means it does not converge by this test. Now, if a series fails criterion 3, which means your series does not go towards 0, your values do not approach 0, then the series does actually diverge, but it's not because of the alternating series test. Criterion 3 is just restating the nth term test, which means if you go back to one of the first tests that we did, in order to converge, your graph has to approach 0, or your sums have to approach 0. So that's the nth term test. If your terms don't do that, then you're not going to be converging. All right, so this says use the alternating series test when applicable to determine which of these series converge. All right, so let's look at the criterion here. Criterion 1 from the other slide. Do these signs alternate? Well, according to this, yes, our signs do alternate. -1 to the n plus 1, that's one of the rules for alternating. N factorial is always going to be a positive value. That's not going to affect anything. So yes, signs do alternate. Do these values get smaller? Yes, they do get smaller as n gets larger, and this does go to 0. And so it does approach 0. Therefore, this does converge. All right, so the next one. If we look at this one, criterion 1, do our signs alternate? We did this on the other page, and yes, our signs do alternate. When n is 0, you get a positive number. When n is 1, you get a negative number. 2, you get a positive number, and so on. So yes, the signs do alternate. However, they do not approach 0. So these values do not approach 0, therefore, or the sums of these values do not approach 0. Therefore, this does not converge by the alternating series test. All right, this one we said before, cosine of n pi, that causes your signs to alternate. So we looked at that before. So the signs do alternate, and our values are approaching 0, and the values are getting smaller and smaller, and they're approaching 0. So yes, this does pass the alternating series test, which means this series does converge. And this one we saw before. This one does not converge because this does not have alternating signs, as we saw in a previous slide. All right, so the next one here, this does cause our signs to alternate, so we do have alternating signs. And then if you think about 1 over the square root of n, all right, well, 1 over the square root of n, if all we had was this series right here, that would be a divergent p-series. However, if we look at this in conjunction with that, in relationship to the alternating series test, do the signs alternate? Yes. Do the values get smaller and smaller? Yes. Do the values approach 0? Yes. Therefore, this does converge by the alternating series test. All right, let's look at the next one here. This right here does cause our signs to alternate. All right, so we do have alternating signs. Now, if we think about n over n minus 1, all right, starting with a n value of 2, all right, so that would give you -1 squared, which is positive, 2 over 2 minus 1. All right, so that would be our first term. The next term will be when n is 3, you're going to get a minus, because a -1 raised to the third power is a negative. then you would have 3 over 3 minus 1. All right. Then the next term would be when n is 4. It's going to be a positive. Then you're going to have 4 thirds. So yes, the signs are alternating, and the denominator is always 1 less than the numerator. So you get plus 6 fifths minus 7 sixths plus 8 sevenths, and so on. Does this pass the alternating series test? Well, the signs do alternate. However, these values are not approaching 0, which means this does not pass the alternating series test. Or in other words, this does not converge based upon the alternating series test. All right, the next one, and in fact, this does not, that actually does diverge, but that's because of the nth term test. All right, so the next one, we're looking at this right here. So n is 1. I'm going to rewrite this as -1 raised to the n squared plus n over 2 times 1 over n. Now, if you think about this part, that part is a harmonic series. A harmonic series diverges. So in order for this to converge, this part right here will have to cause your signs to alternate. If your signs alternate, then we will have an alternating harmonic series which would converge. So this is what we really need to check, is this right here. All right, so if you start out with n is 1, when n is 1, you're going to get 2 over 2, which is 1. -1 to the first power is negative. So your first term would be negative. Now we move to n is 2. Well, if you put 2 in here, you're going to get 2 squared is 4 plus 2, which is 6. 6 divided by 3 is, 6 divided by 2 is 3. -1 to the third power is a negative value. Well, negative means that our terms are not alternating signs. It is not strictly alternating. Therefore, this does not converge based upon the alternating series test. Now, there are some other topics related to alternating series. We could be talking about error. That's not going to be on the AP exam there. We also have something that is called absolute convergence and conditional convergence that we will not be testing on this year. All right, so that's about it for your alternating series test.